Our next section is the adrenal cortex. The adrenal cortex is very challenging for most students. It's long, has a lot of numbers into the enzymes, complicated. It's really like studying 3 chapters in one, because the zona glomerulosa acts like a different organ than the zona fasciculata and reticularis. You should expect to have to go through this chapter more than any other single chapter in the entirety of the physiology section, because it's got so many steps to it. So if you don't get it on the first 1 or 2 times through, you should not be surprised at all. Matter of fact, you should be surprised if you get it on the 3rd time. So here's our adrenal gland cross-section. It's a very tiny gland, about 7 grams. It's added to the renals. Addition de sus riñón, added to the renals. The capsule on the outside edge. The cortex has 3 zones that if we looked at it more closely, you'd say one part of it looked like glomeruli. The other part of it looked like fascicles, which is bundles, fasciculata. The third part, near the medulla in the bottom, looks like a network, or reticulum. Just remember, reticulum is a $5 Greek word for network. The adrenal medulla is going to be encased in a separate chapter because we want to focus just on the complexity of the cortex. What makes a zone in the adrenal is what enzymes are present there. For instance, in the zona glomerulosa, you have certain hormones made, the aldosterone, but they're made there because the enzymes are different. All the zones start with cortisol. No, not really. They start with cholesterol. So cholesterol is at the origin of aldosterone, cortisol, and the androgens. The medulla acts like a separate organ in the center there. That's why this, again, is so complicated, because the medulla in the middle is a virtually completely separate entity making catecholamines. The zona glomerulosa should really be called the zona aldosterona, because that's what it makes. And angiotensin II and high potassium, not low potassium, high potassium, stimulate the zona glomerulosa. The fasciculata and reticularis, although they make 2 different things, the fasciculata making cortisol, corticosterone, and the reticularis making androgens, are both under the control of the same pituitary hormone, ACTH. And what is the feedback inhibition on ACTH? Only cortisol. There's an excellent question for you. Which of the following is the only feedback inhibition on ACTH? Cortisol. That's it. Just cortisol. Saying that ACTH stimulates androgens, but androgens don't have feedback inhibition on ACTH? That's what I'm saying. Because the mineralocorticoids control blood pressure, and the terms mineralocorticoids and aldosterone are essentially the same, there are some hormones that act like aldosterone, but it's still saying like aldosterone. Mineralocorticoids and aldosterone are the same thing, because the mineral it's controlling is sodium. The question says, loss of which zone results in death the most rapidly? The answer is zona glomerulosa. If you lose the fasciculata and reticularis, what happens? Well, you're no fun on a date, you're no fun at parties, but you don't die. Isn't that saying the same thing? Loss of which zone results in death, glomerulosa, is the same thing as saying loss of the other zones does not result in death. Well, our book is very, very big on saying these things twice so we make sure people get it. So we'll say glomerulosa loss will kill you, the other zones won't kill you. It may sound to some people as if we're saying 2 different things, but we're not. When you lose the mineralocorticoids, you lose sodium. When you lose sodium and you lose water, you lose blood pressure. And if there's one thing that we can't tolerate, it's the absence of blood pressure. That's death. Circulatory shock. This is why Waterhouse-Friedrichsen, remember Waterhouse-Friedrichsen? That's meningococcus zapping out your adrenals. And you're expected to know it's from the loss of the glomerulosa. It's because the other way we maintain blood pressure is with norepinephrine at the neurons. A loss of the zona glomerulosa will kill you. The fasciculata and the reticularis make the glucocorticoids, cortisol. And also, it contributes to the loss of blood pressure. But the zona fasciculata is where you're going to make the cortisol. And cortisol also, if you lose that, you'll also lose blood pressure. Not as bad as glomerulosa, but you lose some blood pressure. Because remember, there's a permissive action of catecholamines with cortisol. Cortisol raises blood pressure by having a permissive action on catecholamines. And also, without cortisol, you can't get energy out, so you lose your nutrients like free fatty acids and glucose. Well, let's take our first look at this very complicated hormone pathway. So on the left-hand side, you will see the words LDL towards cholesterol and acetate. This caused the movable feast through your body with the LDL is where the cortisol comes from, it's where the aldosterone comes from, it's where the androgens come from, and all has its sourcing on cholesterol. LDL is like a dessert cart going around your body saying, hi, would you like a little cholesterol so you can make your hormones? Now, the acetate is there to show you that, believe it or not, you actually can make cholesterol de novo out of acetate under conditions of starvation. Desmolase gets the whole party started on the whole pathway. The pathway on the far left is the glomerulosa. Now, the intervening steps of pregnenolone and progesterone are not important in the adrenal because they don't circulate. There's no pregnenolone receptor. It doesn't become important until you get to the 11-deoxycorticosterone. 11-deoxycorticosterone can keep you alive, meaning if you have an 11-beta hydroxylase deficiency, 11-deoxycorticosterone will be able to maintain blood pressure. As a matter of fact, it even causes hypertension if it's in excess because 11-deoxycorticosterone acts like aldosterone. Now, on the bottom of that, where it says C21 at the bottom, C21 is saying that there's 21 carbons in everything that comes out of the glomerulosa and the fasciculata. Now, on the different carbons, you have different shrubbery, different side chains, different groups hanging out there. So you could say, well, I'm throwing on a hydroxyl group on carbon 21. I'm throwing a hydroxyl group on carbon 11. But all of them in the fasciculata and the reticularis have 21 carbons. Now, into the center pathway, you see the word 17-hydroxysteroids made by 17-hydroxylase. Now, the terms 17-hydroxysteroid and cortisol can be used interchangeably. 17-hydroxysteroid and cortisol are an interchangeable term. 17-hydroxysteroid and cortisol. And the intervening pathways in the center, in the fasciculata, 17-hydroxypregnenolone, 17-hydroxyprogesterone, and 11-deoxycortisol do not circulate. There is no receptor, and they're not very important because they're only intervening steps. On the far right, you see that C19, carbon 19, 19 carbons, is the same thing as saying androgens. 19 carbon steroids is the same thing as saying androgens. 19 carbon steroids, the same thing as saying androgens. Now, there's a ketone group to make it DHEA, and you can think of DHEA and androstenedione as interchangeable. You do not have to learn about them differently. They are interchangeable. They're adrenal androgens. Now, although you see testosterone and estradiol on this diagram, it is only to show you that in the gonads, the precursor steps are the same steps that are going on inside the adrenal gland. But the gonads go further. The gonads go further because they have other enzymes. For instance, this is not saying that testosterone and estrogen are inside your adrenal. They are specifically not in your adrenal. But the gonads take the same early steps and go further into testosterone and into estrogen. Everything in the glomerulosa and the fasciculata has 21 carbons. C21. The 21 hydroxylase or 17 hydroxylase is telling you where you're putting extra side chains on. 17 hydroxysteroids has a hydroxyl on position 17. Now, the only significant 17 hydroxysteroid is cortisol. It's also the answer to what is the only one that does feedback inhibition on the pituitary. None of the others do feedback inhibition on the pituitary except cortisol. Now, the lipid-soluble 17-hydroxysteroids gets metabolized to water-soluble compounds when a small amount of them are sugar-coated and taken off their protein carrier. Now, generally, steroid hormones are all on a protein carrier. A small amount, about 1 or 2%, is taken off, and that's why we only can monitor indirectly from that 1% that's free. It's the same way that we would say in GI physiology, saying that sugar coating bile makes it water soluble so you can absorb fat. But the glucuronidation, the sugar coating of cortisol, takes it off the protein carrier and it goes out into the urine. This is also the basis of the test, the 24-hour urine cortisol, because it's the 24-hour urine cortisol that is our best test for determining, do you have hypercortisolism? Not the location, but let's measure what you see in front of you right now. The water-soluble glucuronidated version is the best initial test to answer the question, does this patient have hypercortisolism with the 24-hour urine cortisol? Adrenal androgens and 19-carbon steroids are synonymous terms in the adrenals. You have 19 carbons with a 17 keto, a keto group at position 17. 17 keto steroids is the same thing as saying adrenal androgens. Now, adrenal androgens in their normal circumstances are a clinically irrelevant intermediate step. Only under conditions of excess, such as in congenital adrenal hyperplasia, do they matter. And they matter in pregnant women where we use the fetus's adrenal to give us an extra sex hormones for mom. Now, DHEA is the only water-soluble steroid hormone on a routine basis. The sulfation means water-soluble. Sulfation means not going to be on a protein carrier. So DHEA is sulfated as the only water-soluble steroid hormone. DHEA and DHEA sulfate, androstenedione, are the only water-soluble steroid hormone. Excess production of adrenal androgens doesn't result in a clinical consequence in a man. As a matter of fact, we don't have a pathologic version of androgen excess in men. We only have pathological versions of androgen excess if they occur in women. In a prepubertal male, however, you get early secondary sexual characteristics such as starting to get hair early, male pattern hair loss, deepening of voice, all prematurely. It's in women, however, the greatest manifestations happen. For instance, society has pretty much accepted male pattern hair loss, as long as it's in a man. Society has not been too accepting of male pattern hair loss in women. So having a bald on the head, hairy on the face, virilized female has not gone over very well. The other thing is, why do you get acne when you have virilization? Why do you get acne, pimples? Because all sebaceous glands have testosterone receptors on them. So since sebaceous glands have testosterone receptors on them, it is very easy to get acne when you have excess androgenization and virilization. Remember, 19-carbon steroids is the same thing as saying androgens, and when you have testosterone in the gonads, gonads go further. They're able to further develop these hormones by adding extra things on because they have more enzymes on them. The Leydig cells make testosterone. Now, Leydig cells don't make the sperm. As a matter of fact, neither do the Sertoli cells exactly make the sperm. They just provide a nice environment for it. It's like a hotel room. Hotel rooms don't make people, but they provide a nice environment for them. Testosterone is literally made in the Leydig cells, the same way that in the female, the theca cells make the androgens, and the granulosa cells convert it into estrogen. Leydig cells act like satellites making testosterone around the testes. And so the active hormone is lipid-soluble and not exactly a 17-keto steroid, because remember, testosterone, although it's got 19 carbons, the term 17-keto steroid specifically means adrenal androgen. And when they're metabolized and converted to 17-keto steroids, they become water-soluble. That's the DHEA. This also gets filtered by the kidneys once it's in water-soluble, and remember, DHEA is water-soluble. The other part of it is that we can measure urine levels as a way to tell us what the average blood level is over a day. Leydig cells go further than the adrenal because they have more enzymes. A 17-keto steroid is an index for all the androgens. And females and prepubertal males, urinary 17-keto steroids tell about the urinary levels for an average over a period of time. Not just one urine sample, but if somebody wants to know what you're doing, they can go through your garbage for a week. And then I'll tell you what you've been doing all week long by seeing what you excrete, the same way it is with urine levels and on hormones. So in adult men, urinary 17-keto steroids are 2/3 adrenal and 1/3 testicular. And this is still an indirect measure of adrenal activity. 18-carbon steroids is estrogens. Now, I would not get too caught up onto whether you call it estrogen, estradiol, estriol, estrone. We do know that you convert androgens into estrogen by snipping off one carbon rib. So we know that one carbon is what separates the boys from the girls, the men from the women. When you remove one rib, you make woman. There's Conrad Fisher theology. Lo, we did remove one rib from the man and created woman. Well, how do you know it's not removing one rib from the 19-carbon androgen backbone? Probably could be. And then you make woman out of that. And that's what aromatase does. It's a carbon snipper. So cholesterol gets converted to pregnenolone. Pregnenolone ends up being one of the starting points in the synthesis of the steroid hormones. And it gets transmitted there with a steroidogenic acute regulatory protein. What a great idea, right? STAR, man, STAR. Steroidogenic acute regulatory protein. Wow, cute. And that's desmolase, and it's a rate-limiting step in the formation of the hormones. Converts cholesterol to pregnenolone, catalyzed by chopper cleavage, chopping your side cleavage and chopping my cleavage and I feel better. All that stuff basically to say pregnenolone is a starting point, but it doesn't circulate. There's no independent pregnenolone receptor. The zona glomerulosa can also start with angiotensin II. Now, this is one of the things that make people understand that that's why you don't have to have ACTH, because the glomerulosa can also get started with angiotensin II. It touches the receptor, angiotensin II or potassium touches the receptor stimulates the G protein, the G protein sends a second messenger to start the process of side chain clippers and ends up in aldosterone. 11-deoxycorticosterone is a very important hormone because it can circulate under excess amounts. The other thing about 11-deoxycorticosterone is it maintains blood pressure so that if you can't make aldosterone, if you have 11-deoxycorticosterone, it can end up being very significant for maintaining blood pressure to normal levels or even to excess. This is one slice of the adrenal showing just the glomerulosa. No zone has all the enzymes. That's why you have 3 different zones, and it acts like a separate organ. You can get the cholesterol off the LDL, or you can get the cholesterol to make it de novo out of acetate. The zona fasciculata and reticularis are both under the control of pituitary ACTH, adrenocorticotropin hormone. And the normal hormonal output of the fasciculata and the glomerulosa is corticosterone. Now, 11-deoxycorticosterone is something that can cause you to maintain blood pressure sometimes, but the major issue is the fasciculata. It makes the cortisol, and the fasciculata is the one that makes the 17-hydroxysteroid. Cortisol is the only feedback inhibition on the pituitary. And hormonal control of the zona reticularis is adrenal androgens, but it gets started with the same ACTH that makes the cortisol. Looking at the next section, we're going to go back to this picture and look at the fasciculata in the center, which makes cortisol, and the reticularis on the right-hand side, which makes androgens, both under the control of ACTH. The term 17-keto-steroid is synonymous with the term adrenal androgens. 17-keto-steroids is the term, same as the term adrenal androgens.